Ladies and gentlemen, folks, I would like to introduce you to one of my favorite PMs at Red Hat. They're all my favorite PMs, by the way. Don't feel special, Siamak. But Siamak Sadeghianfar is definitely here to bring some GitOps, the essential Kubernetes workflow is the title of his talk. He's definitely going to talk about some of these questions we have asked here in the Q&A about like promotion, convergence, and kind of the way the flow should work for GitOps. So Siamak, if you want to start sharing your screen, let me turn off Cornelia's. Oh, I can't turn off Cornelia's. Oh, fun. Oh, Cornelia just left, but her slides are still there. Weird. There we go. Okay. So, Siamak, you see the share slides button there? There we go. All right. Siamak, please introduce yourself to the world and let them know what you do here at Red Hat and for GitOps in general. Thank you.
Sure thing. And hi, everyone. Welcome to the first GitOps Con. I'm really excited to be part of the starting keynotes. Talk a little bit about GitOps. It was wonderful listening to Cornelia as well. It made it a little bit easier for me. I can jump over some of the definitions and concept that you have already heard from Cornelia. I'm Siamak Sadeghianfar, product manager at Red Hat as a part of the OpenShift team. And I today want to talk to you about GitOps and how it fits the Kubernetes model. Why does it even fit the Kubernetes model? So there are a lot of similarities that we see, and through the talks we have with the conversation I have with customers, I want to talk about some of those findings that come to the surface. But if you're at KubeCon in like this week, so you're familiar with Kubernetes as one of the main projects, part of CNCF, and it is a container platform, container orchestration tool. But if you think of what it really does for us, it's a declarative approach to infrastructure. So that was really the key of how Kubernetes changed the way we look at infrastructure. So we used to, when we wanted a piece of infrastructure for deploying application, for example, we used to open a ticket perhaps for a VM to be requested. A VM gets created and then handed over to the next team to assign network to it, and the next team to assign storage to it, and so on and so on. Maybe after a week in the best case, or 6 in the worst case, you would get that infrastructure ready for you to be able to deploy your apps on it. And the second time you do that, what you get is probably a little bit different from the previous VM you got. What Kubernetes did for us was that it turned that approach into a declarative one, which means that you describe what you want. In case of Kubernetes, that's in form of a YAML document or a JSON perhaps. So that's your desired state, what you expect. You give that to Kubernetes, and Kubernetes actualizes that. So makes that a reality and brings that up for you. It creates that in form of pods and networking, gives it an IP and perhaps some pieces of storage and a load balancer and so on, and brings the current state to what you had desired. So this model of operating infrastructure has been a huge enabler for a lot of the organizations that wanted to become a lot faster, to be able to deliver applications faster. Like this is not directly related to application, but in order to deliver application, you have to have the infrastructure in place. So that has been this level of automation that Kubernetes provided is something that has been extremely difficult to this level to achieve for many of the organizations. Public cloud were the only one, basically, the providers that could provide this level of automation. And Kubernetes really democratized that type of automation. So you could, everyone on any type of infrastructure, if you're running on your own VMs on VMware or OpenStack or Red Hat virtualization, or on physical server bare metal, you could still have the same type of declarative approach and rapid way of getting access to infrastructure. And especially this opened the door for many of the self-service manners that we see organizations do today, that they allow the dev team themselves request what they want, and this is immediately provisioned for them. not through a ticket that goes to a team and the next team and next team and so on. And because of this level of agility that Kubernetes provided for infrastructure, we see a huge surge in adoption of Kubernetes. So 83% of respondents in the survey that CNCF did last year. CNCF every year does a survey about the state of various projects in CNCF, and 83% responded that they are already running Kubernetes in production. And even a larger number, they're running it in pre-production, but 83 is where they're running it in production. And in the same survey, you also can see the number of clusters, the breakdown of how many clusters those respondents are running. And you can see the increase in the number of clusters per organization. So organizations are becoming more and more mature, more and more comfortable operating Kubernetes platforms. And they are moving to a direction that instead of having 1 or 2 clusters, they have 5 or 10 or 20 or 50. We talk to customers that talk about having a single cluster for every team because they are very confident and capable in operating Kubernetes as a platform. They provision one for the team, and that team is owner of that Kubernetes platform. So this addressed the agility that we needed at the infrastructure level, made it really simple for developers, dev teams to get access quickly, as much as they need, as quick as they need to infrastructure. And with that come, however, a number of complexities and issues for us as well, because we have a very easy time to get access to the clusters, to infrastructure capacity, to compute, to memory, and so on in a self-service manner. But now, instead of that traditional model of the organization having 2 production environments, the production environment might be 20 different Kubernetes clusters, perhaps across multiple infrastructure as well. Some of this might be on the public cloud managed Kubernetes instances. Some of them might be on premises, an OpenShift platform, or an OpenShift on public cloud. So a combination of this. So they don't always look alike. There are different flavors of Kubernetes as a part of this fleet that an application needs to get deployed to. And these clusters also have a highly dynamic nature in some of the organizations. I talked to a customer that has been deploying Kubernetes for multiple years now within the travel industry. And for them, that 9 clusters that you see on the slide, if you ask them which 9 cluster they are for the production of this application, every week the answer is different, because the clusters they have, their production clusters, are very short-lived. So this week there are 1 9 cluster, and next week there are a different 9 cluster. Some of them have died, and some new clusters have joined the production group of that application. So how do we manage delivering application to such a dynamic infrastructure? It becomes much more difficult to make sure that application, first of all, is on all those clusters, and if it is deployed, it is in the state that you want it to be. They have a consistent way to configure all this application, and once you deploy them afterwards, to make sure that the application is still on all this cluster. One of them hasn't died or hasn't run into an issue that you're not aware of. So with more clusters, we get a lot of agility at the infrastructure level, but at the same time, we get more complexity of how deployment application. How do we manage deployments of application? And if you remember, DevOps started to becoming extremely popular about the same time when containers and Kubernetes broke out in popularity a couple of years back. And automation is one of the centerpieces of DevOps practices. DevOps itself is, of course, much more than just automation and practices. It has a lot of focus on the cultural shift of a more collaborative way and workflows for working with various roles that are involved in delivering software, beyond just IT ops and developers that traditionally we talk about in the DevOps space. But in addition to that, there are application operations, the security, and the QE. There are every role essentially that is involved in the delivery process to work collaboratively toward delivering applications. So the cultural bits are there, but automation as a practice in DevOps has been a key in addressing the challenges of multi-cluster deployment. When we have more complex environments, multiple production environments across multiple cloud perhaps, and automating the delivery process has been extremely helpful for many of the organizations to be able to address this complexity. And this automation in DevOps space manifests itself within the CI/CD practice, the continuous integration and continuous delivery. We heard a little bit about that from Cornelia as well. To put it in simple terms, that's essentially automating every step of the way from when you make a change in your code of the application or the configuration of application until all the way it goes into production. And you hear different terms to refer to this flow from CI to continuous delivery and continuous deployment, and they have slight differences. I'm not going to get too detailed onto that, but one point I want to mention out is that even within the CI/CD, we see a maturity that is increasing over the last couple of years. So if you go back when DevOps started to become a little bit hyped, CI/CD was spoken a lot as one thing. And many of the tools that existed in that space, also they were called CI/CD tools. And with CI, definition focused really a lot more on a change that is made on the application to everything that needs to happen until an application is released. And CD, although conceptually it's the entire process, but we often use it to refer to that deployment stage, the last steps that after release, how do you deliver the application across the environments that it has. So in the beginning, we were smushing these two into one term as one set of technology, one set of tools. So you see a lot of teams that have Jenkins, for example, that is doing the entire CI/CD for them. More recently, over the last 12 months, we started to see both workflows, challenges on the customer side, and tooling that separate these two concepts as individual practices, separate practices that they have their own requirements, their own needs, and behave differently. So CI becomes its own segment, and there are a lot of really useful CI tools out there. Jenkins, I mentioned already. There's GitHub Actions, GitLab Pipelines, Takedown, and other tools as well. And CD became a space of its own with tools that are more focused or exclusively focused on the deployment phase, on the challenges of delivering an application into many environments, a combination of Kubernetes and traditional infrastructure, or with serverless and functions and so on, but deployment being the prominent practice there. They don't solve really the CI part. And you can see a lot of tools appearing both within CNCF and outside within that part as well, like Flux that was mentioned a little bit, Argo CD, Fleet, and other tools appearing here. So we see this separation that is happening in this space, and there is a good reason for that. Is the maturity is increasing, so we are recognizing more needs in the deployment phase that specifically address that multi-cluster deployment challenge that we have. But what does GitOps have to do with all of this? I'm not going to spend too much time on defining GitOps. You already heard about that, but GitOps is really a descriptive way of doing CI/CD. So it's really nothing beyond CI/CD or beyond the DevOps space. It's a very prescriptive way of performing CI/CD. Within the DevOps practices, we talk conceptually about what CI/CD is, the specific process in mind, a specific workflow and a specific tooling. Git is already mentioned in it, or it's mostly centered on Git, although it could be other version controls, but the tooling becomes as part of that description of how it works. So you have you define everything about your application and infrastructure as code, everything declarative, similar to how we talked about Kubernetes. All of that goes to one or multiple Git repos as the source of truth, and you drive the operations of your infrastructure and application through Git operations. So you might be thinking, this is nothing really new. How come this has a new name? We have been doing this for years for developing software, and you're absolutely right. So the concept itself is not really anything new. Using Git or source version control system as a single source of truth, we have been doing that in the development space for ages, really. So for the dev teams, this is the only way to operate. There is a Git repo that contains the source code of the application, and any forms of that application that exists anywhere it's guaranteed that it's coming from that single source of truth, from that source code that exists in that single or multiple Git repos, and all changes go there. And that's really the center of collaboration between all developers. So the idea of GitOps is not really inventing a new workflow, it's rather expanding the use of a very familiar workflow that already exists in most organizations, to reuse that workflow to drive operations as well, infrastructure, application operation, to expand that workflow to beyond just development teams and across the organization to IT ops and application ops. And you might again be thinking that even that part of the story is not that new. Chef has been around for a long time, Puppet and Ansible and SaltStack, and there are variations of that, and Terraform. So there are a lot of popular infrastructure-focused declarative manners also that have been in place, and you have to put those manifests somewhere, and most likely you have been putting them in Git and drive them from there. So that is also true, but that essentially strengthens the thought that with GitOps is really a collection of practices and ways of working that have been in place for a long time, but they were disjoint. They were applied surgically to part of the workflow of application delivery. With GitOps, we have a descriptive way of CICD that really looks at application delivery in an end-to-end manner and proposes a way that all the way from change to production, no matter how many clusters or environments that is, it gives a way to really tie that all together and a way of working across different roles, and with Git being at the centerpiece of this way of working. So with the GitOps workflow, I would call it a declarative approach to application delivery, as opposed to Kubernetes that was a declarative approach to infrastructure. You define what you need, what you want in a Git repo, whatever format that is suitable for that. And for Kubernetes, we're talking, so this would be YAML manifest and other configuration related to that, your desired state. There is a GitOps tool in the middle that is actualizes your continuous delivery flow and make that a reality on those target clusters. So it brings those clusters to the target state of the application that you want, deploys the application on all those number of clusters, and compare the states there to make sure that it matches what you have in Git. And why do we, though, propose in the GitOps? What's the value of doing GitOps compared to how we traditionally deploy applications, which in a lot of organizations is stretching the CI process for deployment? The first value we already talked about is the standard workflow for Git. So it's a known workflow across all different roles, and Git being the common tool across organizations and roles. So it's a very familiar one. The learning curve is low, and the skills already existing in most of the teams. The second one is visibility and audits, because moving operations to Git by default, every change is represented by a Git commit or merge on the Git repository. So you have full visibility into changes that happened to various environments, who made the change, what was the reason, what was the discussions on it, who approved, and so on. And especially when things go wrong, you have failure in one of these environments, you want to backtrack and find the cause of that. This kind of visibility and auditability is extremely useful and helpful to reduce one of the major metrics of DevOps that we use often, the time to recover, restore the service. And having a change in a Git repository representing what has gone into production recently, extremely helpful to be able to isolate what kind of changes need to be reviewed. There is enhanced security. One reason for that is the review and visibility to the changes, obviously, that before they go in production, but also the healing nature of the GitOps process, that you can, through that comparison of the desired state and current state, you can always identify if there is a drift, if there is something has changed either way on the cluster or on Git that you don't know about, and maybe that change was not authorized, to automatically correct it or notify someone at least to come look at it. And last but not least is the multi-cluster consistency. So it makes it really simple to scale this process. If you have hundreds of clusters and all of them need to have a particular application, all of them just need to look at a single Git repo that contains the the configuration for deployment of that application, and that application in a guaranteed identical way would get deployed across all those clusters. Really helps the scaling the deployment as we were scaling on the Kubernetes side of infrastructure side. So what does it look like in practice, though? If I'm a DevOps engineer or a developer or app ops person, and I look at source code, I have registry, I have images, how does that affect my way of working? So the CI process is not really that different from the way you work today. There is a Git repository that contains the source code. There is a CI in place, being Jenkins or Tekton or GitHub Actions or something else, that takes the source code, perhaps build it, runs a set of tests on it. There might be security checks in place, a static analysis, and whatever you need to do till you release that application, that code, as an image into the image registry. So that part is quite as you would expect, in a stepwise type of a pipeline that performs these operations. The CD part, the continuous delivery or deployment part, that's the part that might differ from how you're doing today. There would be a second Git repository that contains a configuration of this application. On Kubernetes, this would contain manifest or a Helm chart perhaps for that application. And the CD process, the GitOps tool in there would look at the Git repo of the configurations and make sure that that is in sync with the clusters that are connected to it. In advanced scenarios, you might have from the CI process even a pull request automatically be generated to the configuration Git repository. This pull request would contain, for example, the updated image digest of the new image that was released for the application. So the PR automatically comes to the config repo, updates the manifest of the application referring to new digest. And after the authorized person reviewing that and merging that change would get rolled out to the Kubernetes clusters there. You might be thinking that I don't want to have two separate repositories. I want everything in the source repo. That is, of course, possible as well. In our experience, it's much more scalable and easier to manage when you have a lot of clusters and there are deltas in between. If you have a separate cluster, a separate repository only for configurations, especially that the lifecycle of the content of these repos are quite different. The frequency of change on the config versus frequency of change on source code, for example, is different. So it's much easier if you have separate one, but possible to have the same as well. And you might note that on this slide, there are like arrows on both ways between the CD tool, the GitOps tool really, and Kubernetes there. And the reason for that is that you really have in the GitOps process, there are two operating modes. You might be pulling into a cluster. So if you have the CD tool, the GitOps running on the cluster, it can look at the Git repo, pull the contents into the repository, into the cluster that is running on, and apply the configuration on it and bring the cluster to the state you want it. But you can also have the push model, that you have a GitOps tool that is sitting outside the clusters and in a hub and spoke type of a topology pushes those application and configuration to those remote clusters. And there are use cases for both of them. We see a lot of customers that are interested in the pull model, but there are also use cases, for example, in the edge cases, there are IoT devices, or you're running single node Kubernetes on a certain number of low footprint devices, and you want to really reduce the amount of workloads that are running on the cluster. Then you might be using the push model to push those configuration to those clusters. So you have the flexibility of really following both of these models. And the difference of the GitOps model here, especially with the CD part and stretching the CI process, is that control loop, which is quite similar to how Kubernetes does, is that once you do the deployment based on the declaration that you have in Git, the work is not done. We constantly monitor and observe the state of the cluster. And if there is a change, there might be a ROG change of somebody changing an image just directly on the cluster. The cluster might be compromised. And the GitOps tool there would identify this change immediately, because it sees that there is a diff between what you have stated as the desired state and what you have on the cluster. And it can automatically react to it, automatically correct it perhaps, or you could configure those kind of processes to let the admins perhaps know, or the SRE engineer to come take a look and see if there is some discrepancy of something that needs attention there. And if you're looking on, if you're on an enterprise Kubernetes platform like OpenShift, so the process would look like exactly the same, but there are certain type of technologies that come with such platforms. And OpenShift, which is the container platform from Red Hat, OpenShift pipelines based on Tekton fulfills the CI part for you. It provides a cloud native way to create pipelines that can build the application and help really in releasing the images, perform security checks on them, and so on in a cloud native way, and push the images to the registry. And then OpenShift GitOps based on Argo CD project. Argo is a CNCF project that will be talked about this week as well. You can set up your CD process that connect Git repositories to Kubernetes and OpenShift clusters and have your configs automatically pulled and deployed to those clusters. And I am actually thrilled today. Today is the day that they have made OpenShift pipelines and OpenShift GitOps generally available. And there's a blog post about it on OpenShift blog as well. Definitely encourage you to read about it. It's an exciting moment at GitOpsCon. And with that, I would really wrap this up and see if there are any questions for us to discuss.
So you did an amazing job, right? So a lot of the questions that were asked last session, I think, were covered, but there is one question here. How does Tekton compare to Jenkins when considering a Kubernetes environment? Or perhaps GitHub Actions is a better as a move away from Jenkins, ? What do you think, Siamak?
So Jenkins, first I separate the GitOps Actions from Jenkins and Tekton. So GitOps Actions is a fabulous tool, extremely well designed. If you're within the GitHub ecosystem and you are able to use a cloud-based CI tool, it works really nicely. I really like that product. I use it myself as well for some of the demos and work that I do. But a lot of organizations are not able to do that, or they have their applications deployed on Kubernetes. So they're looking for a native solution to Kubernetes to drive their CI as well, because what is an application on Kubernetes built up? It's built up of deployment and perhaps a number of config maps or a number of secrets. And the unit of deployment there for that application are pods and containers. And it helps a lot if the pipeline was built from the exact same constructs, because if I have a config map that I in an application, I could easily produce perhaps a config map through my pipeline, right? So the value of Tekton is that all these concepts are really what Tekton is built of. So if you want to do something from a pipeline in a secret, in a pod, in a deployment, in a replication set, for example, you have full access because it's really based on the exact same platform, exact same concept. So the level of interoperability based of the application that is on Kubernetes and a pipeline that is based on Tekton on Kubernetes is unmatched by any other CI tool. So there are advantages that you wouldn't be able to get from other CI tools. But you might be thinking, so I could also run Jenkins on Kubernetes, then my Jenkins instance is running exactly where my application is running. Jenkins, though a hugely popular tool, I've been a user since I remember when I was a kid, and we are huge users at Red Hat as well. But the problem with Jenkins is that it's traditional. It's designed as a monolithic application before Kubernetes even existed, container existed. So a lot of the construct that exists in a container platform do not play well with Jenkins. Jenkins is extremely stateful. You want to run a pipeline, you get an instance of a CI server that you need to maintain, and the assumption there is that everyone is on the same Jenkins instance, and you manage access through Jenkins. You have a shared model of plugins, for example, that creates issues about when you move more toward the DevOps way and have more autonomy in the development teams, then it becomes extremely difficult to give that autonomy to a developer when the plugin system is shared across all the pipelines on a single CI server. So Jenkins fits the more traditional way of thinking about pipeline when you have centralized teams that they were center of excellence for automation. They manage this for all the other teams. But as you move more toward decentralized model teams that are more cross-functional, they own the delivery of their application, that model breaks really fast, and you end up giving them a Jenkins instance. Every single team is Jenkins instance, and you buy a lot of operational overhead for yourself. So Takedown exists on Kubernetes really to address these kind of issues of decentralized model of running pipelines in a way that is native to Kubernetes.
Awesome. Thank you very much. So, folks, we have our first session starting here in mere moments. Thank you again, Siamak, very much for talking and sharing with us today. We really appreciate you coming on.